Okay, so now for points D and B, what are the coordinates? If I look at my figure, okay, here it is little bit important to pay attention for these points. So here first, concerning uh, point D, you should follow the lines, guys, okay? So look, this rod, this rod is in which plane? A, B, D. Look, A is the origin. We moved along the y-axis to be here, and then we moved parallel to x-axis. So we can say that ABD is in which plane? In XY plane. So the coordinates of D and B along Z will be 0. Okay? Now, concerning XY components, for point D, if I look at my annotation, okay? Point D has an x component equal to this distance because this line is from y-axis, okay, parallel to x. So this distance k, which is 3, will be the coordinate of D along x. Concerning the coordinate along y, this is the coordinate along y, it's plus I. So for point D, the coordinates will be along x it is 3, it is along y it is 2, and it is 0 along z. Now concerning point B, also same method. So first for x component, I count from this line, okay, I'm moving backward a distance d equal to 2, so it's minus 2 along x, while it has same y of d, okay, because these two bd is perpendicular to y, so 2 points has same have same coordinate along y, which is 2. So for point B, it is minus 2 2 0, okay, minus 2 2 0, okay.
Doctor,
And
the z
yes,
of d, the z of d shouldn't it be h plus j?
sorry, I cannot hear you well. Can you try to raise your voice, please?
The z of d shouldn't be h plus j, so
No,
it's 2.
no, because look, h plus j is counted from the bottom of the plate, from here. Is the bottom of your plate passing by origin A? Is it the x-axis here? No, the x-axis is at A level, at the level at A. And as if you follow your structure, okay, this rod is along y-axis. So it is along z equals 0. And you do perpendicular to it, okay, along the same plane. So also z equals 0. So these two are in plane xy. The bottom of the plate, the bottom line of the plate is below xy plane. This line is characterized by z equal to minus h minus g. Okay? So here الأوريجين يعني الإكس واي بلين بقلبه عندك الأي بي دي and the bottom plate هي اللي تحت البلين. Do you see it now?
Yes.
Okay. Now, if I will need also coordinates of point G because I want to do some of moments about A. So I need vector position AG. What are the coordinates of G? Now, if you look well at your figure, if you want to to find the coordinates of point G, okay? First, G is below XY plane, and it's below it at which distance? It's
h.
below it at a distance of H, okay? So Z will have a negative, G will have a negative Z coordinate equal to minus H, while along X and Y, if I want to find its component along X and Y, if you look at the figure here, so let me clear a little bit for you to see it, okay? Look, what I know is that the distance from here to here, yani from y-axis perpendicular to parallel to x, it's k, okay? And g is from this line at a distance of f. So what will be the x component of g? if I count it from this line, it will be this distance. Okay, this distance is equal to k minus f. So the coordinate of point G along x-axis will be a positive coordinate, this one, given by, so the x component is k minus f. If I look at my values, k is 3, f is 2.5. So for G, the x component is 0.5. Now, concerning the y component of G. For the y component of G, it is equal to the y components of B and D. You know why? Because look, the whole plate is perpendicular to y axis. So all points of this plate will share same coordinate, which is what? Which is I. Okay? So y component of G is also equal to 2, while z component is negative, and we said it is minus h because the distance from here to here is h, and it's below xy plane, so it's minus 1. So these are the coordinates of all my points. Once I have coordinates of all my points, it becomes just a replacement. Okay, so I will get first the unit vector of DE, I will get the unit vector of BC, and then I can get an expression for TDE and TBC. And finally, when I want to do some of moments about A, okay, what will be the moment of TDE? So the moment of TDE about A will be equal to the position vector, which is, I can take AD and I can take AE. It's up to you. You can select the easiest one. So here, for example, maybe AE is easier. So I can do AE vectorial TDE. And when I want to do, guys, just 1 second to put the charger, please. Okay, so now for moment of TDE about A, I can do AE vectorial TDE, okay? And to get the moment of TBC, so if you want, this is a review of what we did before, okay? Because all what we learned in the chapter of moments and forces is very important in equilibrium. So moment of vector TBC about a point A is equal to, I can do or AC vectorial TBC or AB vectorial TBC, but the coordinates of C both here are the same لأنه they have one zero component and the other components are different than zero. So it's up to you. You can do or AB. So you have the option of doing AB vectorial TBC, or if you want, also you can do AC vectorial TBC. Both will give you the same result. Also here you have two options for TDE, or AE or AD. So also you can say here it's AD vectorial TDE. Now, for the moment of the weight, what is the position vector? It's AG, okay? So when you want to do the moment of the weight about A, you will do moment of weight about A is equal to AG vectorial the weight, okay, vectorial W. So now, once we have found, if you want, the expression of all the components needed, we just have to write our 6 equations, okay? So let us see together the numerical calculation. So as we said, what is the first step? We draw the free body diagram. We put all external forces and reaction acting on the plate. Then we determine all coordinates of point. After this, we will be ready now to write the two vectorial relation. اللي هن أول شيء sum of forces equals 0, okay? And the second one, sum of moment equals 0. Here you can start with sum of forces equals 0. After we have found the components of each force, now we can write sum of x equals 0, sum of y equals 0, and sum of z equals 0. So this relation represents sum of x. All they did, they considered the component of x of each force. Another reaction at A, we have AX. After you calculate the unit vector of TDE and TBC, okay, you can just find now the x component of TDE. شو هو x component of TDE? هو TDE times what? Times the component of unit vector along x. اوكي مش نحن جبنا اليونت vector. This is its x component. هلا هن حاطينها in letters, but if you replace numeric you will see it's very simple. So this is the unit vector component of DE along x-axis. Okay, now the same, you got the unit vector of TBC. So what is the component of TBC along x? It's TBC times the component of x for unit vector of BC. So this is unit vector of BC component along x also. These are the forces along x. So you get a first equation. This is relation number 1. Now the second relation will be sum of Fy equals to 0. Okay, now you will also do the same. You will take the y components of each force. So you have Ay first, the reaction. This is Ay. For the weight, no component along xy, only along z. So you will take now the components of TBC, TDE along y. So you should take the y component of the unit vector of each one. Okay, so this is the y component of TDE, of unit vector of DE, and this is the y component of unit vector of BC. This is equation number 2. I will do the same now for third relation, which is sum of z equals 0. I will write for each force, I will get z component, and I will add them to get my third relation. Sum of z equal to 0. This is the unit vector component of DE along z. This is the unit vector component of TBC along z. Now, concerning the reaction A, it doesn't have a z component. I just still have the weight, so minus W equals to 0. This is relation number 3. Now I got 3 equations, but these equations are not enough because I have 6 unknowns. Now I will move to the second vectorial relation. The second vectorial relation is sum of moments about A equals 0. Please, I want you to try to do the calculation. We have found together all vectors, okay? You have to do B vectorial TBC plus AD vectorial TDE plus AG vectorial W. When you do the expansion of this vectorial relation, you will get components, you will sum components along I equal to 0. You will sum components along J equal to 0. And you will sum components along K equals to 0. You will get then 3 additional equations. The first one represents, this is, okay, this is the sum of moments along X. Sum of moment about A in X equals to 0. Okay, so you cannot find this relation directly. As I directly put it, you should do the expansion or do the right hand rule if you want also, but I advise you in 3D to use the vectorial method. Okay, so by writing the 3 equations, by doing the development and taking sum of I components equal to 0, sum of J components equal to 0, and sum of K components equal to 0, you will get 3 additional equations, 4, 5, and 6. So now what you did is that you wrote 6 equations with, so this is equation 4, this is equation 5, this is equation 6. Now, I don't want you to worry. Of course, I will not give you such problem in exam, but I will give you something simple. I can give you a 3D problem that is relatively simple, so you can write 6 equations that are easy to solve. What I want you to understand is the concept, how we can solve for 3D equilibrium. And as you know, in the exam, I will select small problems for you to have enough time to solve them. Okay, so here we end up with 6 equations, 6 unknowns, which will allow us to calculate all our unknowns, which are the tensions and the support at a reaction. At the smooth color, you have AX, AY, and MAX, MA. Any question on this? So I think, yes, we just still have one problem and we will be done with the equilibrium of a rigid body. Okay, so hopefully next time you can start the final chapter in statics. So with next week nearly we will be done with the statics part and we'll do a small review before the exam. And then after we can start the dynamics. So see you next time. Bye bye.
Thank you, Professor.
Thank you,
Thank you,
Doctor.
Doctor.
Welcome back.